a slope in and of itself and what makes a slope parallel or perpendicular to a line with another slope. So today we're going to actually talk about writing equations of lines that are parallel or perpendicular to another line. And the format we're going to use today is PointSlope Form. It's the easiest format to use because if you have a point and you have a slope, you can easily write it and you don't have to solve anything. So PointSlope Form looks like this. Y minus y1 equals m times x minus x1. And kind of picking that apart a little bit, m is the slope, just like in y equals mx plus b that you might be a little more familiar with. And x1 and y1 are the coordinates of a point on the line. So an equation in this format might look like y minus 7 equals 3 times x plus 2 or something like that. Wow, that's not a great color for this. So an equation like this might look something like this. The only variables that should be left over when you're done writing it should be x and y. All the other things should end up being numbers. So like y1, m, and x1 will all be replaced with numbers. Okay, so let's see what this is going to look like for us. For the first one, we're doing parallel to a given line. And this is where you use the same slope. So we're going to do parallel to this line and through this point. So the first thing that I would do is look at the line that you're given and circle the slope of it. What's that? Okay. So I would look at that line and circle the slope. The slope is 2 in this case. And since we're making a line that's parallel to it, we're going to use the same slope. So I'm going to say the same slope for this one, m equals 2 for our new line. And then the point, the 3, 5 here, is going to be our x1 and y1. So when I write my equation of my line in this format here in the PointSlope form, we go y minus 5, since that was y1, equals our slope, 2, times x minus x1, which was 3. This is my final answer, and we're all done.
That's the answer? We don't have to solve that?
Nope, not today. That's what we're going to start doing next week, is solving for y and putting it in slope-intercept form. Today we're just doing point slope. Make it simple. It's Friday. Keep things easy. All right. Any questions from this one? Anything we're not sure where it came from? Okay. Question.
What is the x minus 3? Why wouldn't it be x plus 3?
Because in this equation format here, we do x minus whatever the x1 value is. If this was a negative 3, then it would be x plus 3. But since it's a positive 3, we go x minus 3. So it's kind of, in a way, it's opposite of what you would think it would be, but we go just based off of this format with minus in between them. Yeah.
If it was like negative 3 and then 5, would it be like x minus negative 3?
Right, which would then you can turn it into x plus 3 if it was minus negative.
Yeah.
Exactly. All right. So the next way we'll do it is perpendicular instead of parallel. So this time you have to use the negative reciprocal slope. So same process though. I would go through and look at my line here and circle the slope. But this time, instead of keeping the same slope, I'm going to take the negative reciprocal. So what's the negative reciprocal of 3/4?
Negative 4/3.
Negative 4/3. All right, so that's the slope we're going to use. Then we do the same process here. This is our x1 and our y1. So we go y minus y1, which was 7, equals the slope, negative 4/3, times x minus x1, which was negative 2. So this is the case where you end up with minus a negative. And you can turn that into adding a positive. So we can rewrite this as y minus 7 equals negative 4/3 times x plus 2. It's the same thing, but just a little bit cleaner with the x plus 2 instead of minus negative 2.
I can't even see. You try.
Okay. The first one for you guys to try, we're going to go parallel to y equals negative 1/2 x plus 7 and through the point 4, negative 2. Go ahead and give that one a try on your own real quick. If you have questions, I'll come around. We're trying that one on our own. No. You have a barcode?
Yeah, but it's like on my phone case. It was on my phone, but now I have my phone case. So now I have to like walk around with like,
Oh, no.
with like an empty case. On just a bar cart, with like just a yeah, just in my pocket, like just a reminder. He wants to the little thing on his desk while he's in the bathroom. So I'm like, where's your phone? I'm like, I have a phone. He's like, I saw you scanning with your phone. I'm like, sir, it's an empty phone case. He was like, no, Mario, where's your phone? I'm like, just scan here with an empty phone case.
All right, talk to people around you about this one. Help each other out.
Okay, I got y minus negative 2, we're gonna turn into plus, equals 4 times negative 1/2 minus 2. Because, we negative 1 over 2. Okay, I got it. I don't think it's right, but yeah, can I just copy it here?
All right, here we go. On this one, we should have gotten that our slope is going to stay negative 1/2. X1 is 4, Y1 is negative 2, so we get Y minus negative 2, which you can then turn into Y plus 2 if you would like, equals negative 1/2 times X minus 4. All right. Any questions from that one? Any numbers we're not sure where they came from or anything like that? Okay. Then you guys get to try another one. This time we're going to go perpendicular. All right, this time. Here we go. Paying attention. If you see something like y equals 1x plus 9 or y equals x plus 9, that's the same thing. The slope is 1. There's an implied 1 in front of the x. So just keep that in mind. Remember from algebra, that's how that works. If you just see an x by itself, that's just like 1x. So we want perpendicular this time to y equals x plus 9 and going through the point negative 1, 4. All right. So find the perpendicular slope with your negative reciprocal. Flip the fraction, change the sign. and then use negative 1, 4 for x1, y1.
Wait, how do you do it?
So what's 1 is a fraction?
You have to do two of
One,
like.
right? So if you flip the fraction, you still get 1 over 1. So I think the sign is negative.
You can choose three.
So negative.
I'm going to straight.
Those are just two different ways you might see that equation written.
So why would you give me a harder option if I was just talking, even it sound no, because there's different with it, there's
So you gotta go y minus y. Y
This is what I.
So y
Yeah, but this is like the money.
So then you'll have.
It's easier than what everyone. It's money.
How do you? You know that you're making this talking about.
So like we don't do anything.
Okay. I can do that.
I just
How do you do that?
I'm not.
Oh, and then the first one. So basically, we go extra, like.
All right, talk to the people around you, help each other out here.
I got. I got y. Negative 1 over 1 times x plus 1.
He's waiting for an answer. Everybody can answer the question.
The same thing. You know what it's something. Yeah, that's the only thing you get to change is math.
And then negative 1.
I'm
just like.
All right, folks, here we go. Paying attention, if you got negative 1 for your perpendicular slope, that is correct. So here's why. If you write 1 as a fraction, it's 1 over 1, right? If you flip that fraction, it's still 1 over 1, isn't it? But you have to change the sign. So it becomes negative 1 over 1, which is negative 1.
Did we put negative x?
Yeah, so if you want to put like, I mean, if we were doing this in slope-intercept form, you'd end up with negative x. In this case, you could put like, you know, when you're doing x1 and y1 here, y minus 4 equals, you could just put negative x minus negative 1. Or you could put negative 1 times x minus negative 1. Either way. You will also want to change this into x plus 1 because minus a negative is like adding. So y minus 4 equals negative 1 times x plus 1 would be your final answer. A couple things that I saw out there when I was looking at people's papers and things real quick, paying attention. A couple things that I saw people using like the number 9 and stuff like that in it. And 9 is part of this line, but it's the part that we don't care about. We don't care about it. Yep. Poor number 9, we don't care about it. Just like up here, just like in this one, we don't care about number 7. We only, from the line that we get that we're going parallel or perpendicular to, the only number we care about is the slope. That's it. That's all we're taking from that line is the slope. We don't care about any other number in that line. Okay. Once you have that, you can go ahead and turn the page. Okay, so here we go. You guys have plenty of time to work on this right now. We're going to talk about a few of these. So here we go. For the first 6 problems, you're writing the equation that goes through the given point and is parallel to the line. For 7 through 12, you're writing the equation that is perpendicular to the given line. So this on 7 through 12, you have to flip the fraction and change the sign on the slopes. What I would do real quick is go through and circle all of the slopes real quick, just so that you know what you're working with, and label all your points as your x1, y1, and stuff like that. That'll at least make it so that we remember what the slope is and where all that's located. So remember, on 1 through 6, we're going to have the same slope. If you want to make a note for yourself there, that would be a good idea. And then on 7 through 12, we're going to have negative reciprocal slope. And then on 14 and 15, this is a review from Wednesday. You find the slope of line AB, find the slope of line CD, and then decide if they are parallel, perpendicular, or neither. Okay. So you guys have some time in class right now to work on this, about 12 to 15 minutes or so. Go ahead and get started. If you have questions or want me to check any, I'm happy to do that. I'll be coming around. Otherwise, go ahead and get started.